Hey, what's up? Today we're going to do proofs for the sum formulas for cosine and sine. So in order to do these two proofs, what we need to do first is come up with what the sine of an angle is and what the cosine is. If you've taken a trig class or you've taken geometry or maybe even algebra, you might know already what sine and cosine is, but we're going to do a little bit of a twist to that. We're going to do a little bit of a twist to sine and cosine. We're going to first come up with the sine of this angle theta. And the sine of an angle, of course, is going to be the opposite of the angle. Here's the angle theta here. The opposite side over the hypotenuse. So we write opposite over hypotenuse. Now we're going to do a little twist here. We're going to solve this formula here. Sine of theta equals opposite over hypotenuse. We're going to solve it for opposite. So in order to do that, we're going to have to do what? Multiply by hypotenuse. Really hypotenuse over 1, same thing, right? And hypotenuse here. And now we've got this formula, hypotenuse times sine of theta equals this, opposite over hypotenuse times hypotenuse. Of course, the hypotenuse cancels out. This is just some basic algebra here. And what you have left is the opposite side can be written equal to the hypotenuse times the sine of theta. So now we have the hypotenuse written in terms we have the opposite side written in terms of hypotenuse and sine. We're going to take this formula and write it up here because we are going to use this in a little bit. Opposite equals hypotenuse. So now we're going to come up with the cosine of theta. And if you've taken trig, or if you're taking trig now, or maybe took geometry, you may already know that the cosine of an angle, and the cosine of theta in a right triangle is going to be the adjacent side of the angle here, the side that's adjacent to theta over the hypotenuse. So we're going to write adjacent over hypotenuse, and we're going to do a little bit of a twist here. We are going to write this formula here, this equation here, in terms, the adjacent side, in terms of the cosine of theta and the hypotenuse. So we're going to say, okay, multiply each side by the hypotenuse, right? Because we want to write this in terms of the cosine and the hypotenuse, and we want to cancel out the hypotenuse. So we're going to do some basic algebra here. The hypotenuse goes away, and we are left with hypotenuse times the cosine of theta equals the adjacent side of theta. And we're going to take this formula right here, and we are going to write it up here because we are going to use it many times in this video, along with the other formula, opposite equals hypotenuse times sine of theta. Okay, so now we've got our two formulas here, and we're going to use these two formulas to come up with the sum formulas for cosine and sine. We're going to start off by making a right triangle over here. So we're going to try and make this as straight as possible. Got a little ruler here. And we've got one side of the rectangle, and then here's the other one here, okay? And so we got a right triangle here, and now we're going to make another angle right over here, extending off, and another one extending this way. Okay, it's not going to be a perfect right triangle, but it's not bad. And we're going to call this angle A. We're going to call this one angle B. So now we've got angle A and we've got angle B, and we're going to now make a right triangle. We're going to extend this up a little bit more maybe. And we're going to make a right triangle from here to here. So now we've got a right triangle here. And we are going to now define each of these sides in terms of the angle B. The other thing we're going to do is we're going to label this hypotenuse of angle B, side of the hypotenuse of the triangle here with angle B, as a distance of 1. Just like if you were to have a unit circle, and this was, let's say this was the y-axis and this was the x-axis, this would be a unit, this would be a length of 1, this would be a radius of 1 in the unit circle. So now that we've got our right triangle with angle B and a hypotenuse with a distance of 1, we can define this side and this side by using our two formulas. So this side here, this is the side opposite of b, and we know that the opposite equals the hypotenuse, which is 1, times the sine of the angle, which is b. So this is going to be the sine of b times 1, which is just going to be the sine of b. So we write in here the sine of b. This angle here is the sine of b. And then we've got this side right here. And this side is adjacent to angle b. So we use our adjacent formula that we came up with earlier. Adjacent equals the hypotenuse, which is 1, times the cosine of the angle, which is b. So this is going to be cosine of b times 1, which is cosine of b. So we write here cosine of b. And now, next thing we're going to do is we're going to extend our right triangle over here. So we're going to extend this all the way. This side here is going to be all the way over here. Yeah. So now we've got a right triangle right here. And this, we're going to define this side and this side in terms of angle A. So angle A is right here. The side opposite is right here. And of course, we use our opposite formula. Opposite means the hypotenuse, which in this case is the cosine of b, times the sine of the angle, which is this a. So this is going to be the cosine of b times the sine of a, or the sine of a times the cosine of b. So I'm just going to call this the sine of a, cosine of b. And again, multiplication is commutative. So originally I said cosine of b times sine of a, but sine of a times cosine of b is equal to cosine of b times sine of a, since multiplication is commutative. Now, we have to figure out this other side right here. This side is adjacent to angle A, so we use our adjacent formula, and our adjacent formula tells us that the hypotenuse times the cosine of the angle equals this side. The hypotenuse in this case is the cosine of b times the cosine of the angle, cosine of A. So this is going to be cosine of A times cosine of b, or cosine of A, cosine b. So I write here cosine of A, cosine of b. So now I've got cosine of A, I got this side, these sides defined, I got these sides defined. Next thing I'm going to want to do is I'm going to want to finish a rectangle right here. And I'm going to have this come up like this. So now we've got a right triangle right here. We've got a right triangle right here. And we just want to, next thing we want to do is define what are these angle measures here. We know this angle measure here is A, and this is 90. So how big is this angle right here? Well, this angle is going to be, as we know they're in a triangle, there's 180 degrees in a triangle. So this is going to be 180 minus 90 in a right triangle minus A, which comes down to 180 minus 90, which is 90 minus A. So this angle right here can be defined as 90 minus A. Now we want to see how big is this angle right here. Well, we know that this right here going across from here to here is a straight line, so it has 180 degrees. So if we want to figure out what this angle is, we take 90 degrees here, we subtract 90 from 180, and then we also need to subtract this other angle here, 90 minus A in parentheses, because we want to subtract this whole amount here. And then we just simplify. We say 180 minus 90 is going to be 90. And then minus, we distribute our minus here. So we get minus 90 and plus A, because minus times a minus is going to be a positive A there. And then we simplify. 90 minus 90 is going to be 0. 0 plus A is going to be A. So this angle right here is angle A. So we've got that as angle A. And okay, so it's interesting to note here before we go on that if you look at this rectangle here, we've got four triangles, four right triangles within it. We've got one right triangle here, another one right here, a third one right here, and a fourth one right here. Right now we're working on this third one right here with angle A, and we're going to define this adjacent side and this opposite side in terms of angle A. And so we're going to start here. This side is opposite of angle A, so we use our opposite formula, which says that opposite equals the hypotenuse, which is the sine of B, times the sine of the angle, which is A. So this is going to be the sine of A times the sine of B. So we have the sine of A times the sine of B here. Now we're going to do this side right here. This side is adjacent to angle A. So we're going to now use our adjacent formula, which says that adjacent equals the hypotenuse, which is sine of B, times the cosine of the angle, which is A. So now this is going to be the sine of B times the cosine of A, or we'll write it as cosine of A, sine of B. Again, multiplication is commutative, so the cosine of A times the sine of B is the same as the sine of B times the cosine of A. Now what we're going to do is we're going to work on this right triangle right here. First, we're going to figure out how many degrees is this angle right here. Well, again, as we mentioned, this is a rectangle, so this is a right triangle. This is a right triangle right here, and as such, we have angle A and angle B plus this angle here equals 90 degrees. So we say this angle right here is going to be 90 minus A minus B. And so we define this one as 90 minus A minus B. Write that right here. And next, we want to figure out what is this angle right here. Well, this is a triangle. Triangle has 180 degrees. So we are going to define this one right here as 180 minus 90 for the right triangle, minus 90 minus A minus B, all in parentheses. Minus 90 minus A minus B in parentheses. And we just simplify here to figure out what this angle measures. So 180 minus 90 equals 90. And then we have this minus we're going to distribute to the 90, to the negative A, and to the negative B. So we have minus 90 plus A, because a minus times a minus is a positive. And then minus times minus here is a positive B. And then the 90 minus 90 goes away. So we end up with A plus B. So this angle right here is A plus B. So now that we've defined this angle here as A plus B, we can now define each one of these sides, the side opposite to A plus B and this side adjacent to A plus B, using our two formulas that we did at the start of the video. So this side here is opposite of A plus B, so we say opposite equals the hypotenuse, which is 1, times the sine of the angle, which is A plus B. So now this side is going to be sine of A plus B. So we've got this one defined as sine of A plus B, and we write that down right here. And now we have to figure out this adjacent side. And of course we use our adjacent formula, which says the adjacent equals the hypotenuse right here, which is 1, times the cosine of the angle, which is A plus B. So we have the hypotenuse, which is 1, times the cosine of A plus B, which of course is going to be cosine of A plus B. So we have cosine of A plus B right here. Now we can erase all this right here. Now, ladies and gentlemen, we are just about ready to kick this trigonometric party into high gear. If you've always wanted to know why the cosine of A plus B equals what it does, or why the sine of A plus B equals what it does, it's all laid out right here in this masterpiece that you and I have both created. Let's start with sine of A plus B. Where in our rectangle do you see sine of A plus B? Looking around here, there it is right there. And again, this is a rectangle, which means that this whole length here, which equals sine of A plus B, has to be equal to this whole length up here, which means that the sine of A plus B equals the sine of A cosine of B plus the cosine of A sine of B. Again, this whole length right here represents the sine of A, and the sine of A this whole length here represents the sine of a plus b. And therefore, this whole length here, since this is a rectangle, is equal to this length. So the sine of a cosine of b plus the cosine of a sine of b is going to be what the sine of a plus b equals. Now, what about the cosine of a plus b? Where is the cosine of a plus b on our rectangle? Looking around here, there it is right there. And again, this is a rectangle, so this side here is going to be equal to this length right here. And we notice that the cosine of a plus b goes from here to here, and therefore the cosine of a plus b would be equal to this whole length right here, cosine of a times the cosine of b, minus this length right here, sine of a sine of b. And that's how you come up with your cosine of a plus b. Again, this is a rectangle, so this side equals this side. And since the cosine of a plus b is this length right here, it is equal to this whole length, cosine of a times cosine of b, minus this length right here, which is the sine of a times sine of b. And there you have your cosine of a plus b. There you have your cosine sum formula. Thanks for watching. Hope you enjoyed this trigonometric party. Please feel free to rate this video, leave your comments, and subscribe to our channel. And check out these videos on the left-hand side of your screen, which includes a video on the difference formulas for sine and cosine. Until next time, rock on, people!